This is the technical session on new machining strategies for die mold industry, barrel machining, trochoidal milling. We have Mr. Sashi Menon who's coming on. He's a cutting tool expert.
Actually, I'm very happy here because before my session, the last words were about NTTF. I'm an ex-NTTF. 1979 batch Talasheri. Okay, I'll come to my presentation. Okay, let's come. Profitability in milling. Profitability in milling, what does it depend upon? Of course, it's something like this only. If you want to have the profitability. So it depends on several other things, but productivity is one of the factors of that. You have to take the workpiece out of your machine as soon as possible. So how do we do that? Again, lots of factors are there. And one of the major factors is MRR, material removal rate. Yes, again, for material removal rate, there are several possibilities out there. But one possibility, one is this, your strategy. What milling strategy you are going to use to remove the material as fast as possible. That leads to productivity, and productivity leads to profitability. So I'll be talking about two methods. One is trochoidal milling, and the other is barrel milling. Trochoidal, I think most of the people are using trochoidal milling now, but barrel machining is just coming up. So I'll try to talk about both of this. So what is trochoidal milling? This is a trochoidal milling path, what you see here. Most of the time, people think trochoidal milling is only for opening up a slot. But trochoidal milling has lots of possibilities. I'll show some videos and all those things for that. Trochoidal milling means creating a bigger area than the cutter diameter inside a cavity or so. Use a small diameter cutter, you make a big cavity or a big slot. So in that, this is accomplished by using a series of circular cut known as trochoidal tool path. It's like this. The cutter, small cutter, it uses some circular tool paths and opens up the cavity or the slot, whatever we have to machine. Okay. So advantages, I'll just talk about advantages. One is you are getting low cutting forces. Second, I'll explain why it does that. So because of that, it is suitable for weak work holding systems. So if the fixture is not that strong, your trochoidal milling can help you a lot in that. Less chance of vibrations, because cutting forces are less, that means the chance of vibrations are less. Reduced heat, because of that, reduced heat means your heat at the cutting edge is reduced. That means the tool life can improve. Then you can use continuous down milling paths and can be used for roughing as well as finishing. Both for roughing as well as finishing, you can use trochoidal milling. Basic idea is to use a small radial engagement. That is why AE and a larger AP. Small AE, that is engagement, radial engagement, and a larger AP, high depth of cut and small engagement. And that is why you are having low heat generation of the cutting edge, because your engagement is less. What happens then when your engagement is less? The average chip thickness, that is HM, will decrease. When your engagement is less, the average chip thickness reduces. Because of that, the amount of heat produced at the cutting edge also reduces. Okay. Now, what's the advantage of that? You can use for high cutting speeds. Because cutting speed is the major reason for developing the heat. All of us know that. And when you increase the cutting speed, because of the low AE, you can increase the low chip thickness, you can increase the cutting speed. Similarly, feet per tooth. This also can be increased to compensate the reduced chip thickness. Chip thickness is less in this case. So in order to compensate that, you can increase the chip thickness, you can increase the feet per tooth also. Naturally, if you increase the feet per tooth and cutting speed, your table feed is going to be higher. Then you have a large AP. Combined to that, high table feed and high AP will give you the cycle time will be reduced considerably. Then another part is axial forces. Why I said that vibrations will be less. Axial forces are things that will really push the cutter. And that's why the vibration can happen. But in this case, axial forces are less. So that pushing won't be there too much. Of course, the pushing will be there, slight vibrations will be there, but not compared now, what do you call it? since the less AP is there, the vibrations will be minimized because of the, the axial force, radial force are less. Axial forces is like this, sorry. Axial forces are like this. That depends upon the depth of cut, that will go directly to the spindle. It won't affect much for the vibrations. But radial forces, it is what is pushing the cutter. So this is affect the spindle also. So this is, since the radial forces, A is less, the radial forces are less, that will reduce the vibrations. Then, since small HM will reduce radial cutting forces, lesser chance of vibrations and spindle damage. And it can increase tool life, especially while machining self-hardening materials. Self-hardening, like superalloys, stainless steels, these are self-hardening materials. What is self-hardening? When the cutter passes, it will create a hardened layer at the bottom. So when the next pass comes, the cutter again is passing through the self-hardened area. Again, third pass, self-hardened. Fourth pass, all the time the cutter is having that getting engaged at a portion, the cutter will engage at a portion with the hardened surface, and then it will create notch wear. So the more number of passes, bigger the notch wear will be. So here what we are doing is, okay, this is what I said, generate while machining. In traditional milling, every cut will have to face a hardened layer. So that means the notch wear will be, more number of passes, the notch wear will, higher there will be notch wear. Now, with trochoidal milling, material is removed with a fewer pass, or in most cases with one pass. So it is not facing the hardened layer. So the chance of notch wear was almost zero in the case of trochoidal milling, because it is not, the hardened layer is not coming in front of that. So that's very big advantage, especially when you're machining self-hardened material. Like this is one of the best methods for machining superalloys, titanium and all these materials. This is one of the best methods of doing that. Since either you are using a single pass, most of the time you can remove, if you've got a good cutter, you can remove the material with a single pass. So the notch wear will be reduced, and there will be enough space because you are using a small diameter cutter to open up a larger area. So you have got a lot of space for the chip removal. Plus, upon that, there will be, when you are having a, this sort of cutter, this will have high number of flutes can be used. Then again, your table feed increases. So this is one good method, you can go that. But you can't use any cutter for trochoidal milling. You should take care of the cutter also. It should have a very strong core. Then you should have a large flute length, of course. For the high depth of cut, you need a large flute length. Then strong chamfer or corner radius like this. This is very important. It should have a very strong chamfer or a corner radius, big corner radius. Otherwise, the area will chip off because the high depth of cut it can chip off. Plus, serrations along the cutting edge. If you have this kind of serration, okay, this kind of serration along the cutting edge, this will again reduce the cutting forces because total contact is not there. So, trochoidal milling is a good method. We'll have a video. Sound. See, this is generally people think trochoidal milling can be used only for opening slots. That's a common mindset of the people, but it's possible to do all these work, especially when you are machining your punches. Any profile can be, of course, not a copy milling cutter, and then any straight profiles, the corners, everything can be done with this. That was a movie. Now, I'm going a little bit fast because the time also is. So next is barrel milling. This barrel milling cutters has been there for quite long period. These are the 4 parameters what you have to, all of you know, all of us knows that. 4 parameters while we are machining, these are the parameters what we use. Of course, depth of cut, then the feed per tooth, radial depth of cut. Radial depth of cut is called as step over, pitch, all these things, but it's called as AE, and cutting speed. These are 4 parameters what we are using for machining. Okay. Now, productivity in roughing. Of course, we have to remove the material. Material removal rate has to be high. Can you increase the depth of cut to productivity in roughing? Of course. Increase the depth of cut as possible. Feed, increase the feed? Yes. That also is possible. Increase step over? Of course. That's also possible. These are the basic things of increasing productivity in roughing. What about cutting speed? Can we increase the cutting speed? I'll say, because most of the time when you are going for roughing, you will be using a cutter or insert which is having high, little bit more cobalt content, and this will be tougher inserts. For that, the cutting speeds, because when you are going for high depth of cuts and high feed rates, your cutter should be strong. So the cobalt content will be little more. When you are using the roughing tools, the cobalt content will be more in that. So cutting speeds, yes, you can increase, but not too much. It's something like this. You have to check that. Now, this is okay. With this productivity in roughing, you can increase the depth of cut, you can increase the feed, you can increase the step over, you can increase the cutting speed if you want. Now, productivity in finishing with ball nose. Can we increase the depth of cut? No. Because you already decide, after roughing, you already decided what should be a material to be removed. That's decided, you cannot do anything in that. Even if you do anything, nothing will happen over there. What about increasing the feed? No. Because if you increase the feed, your surface finish is going to get spoiled. Now, what is left? Increase step over, increase cutting speed. Increase cutting speed, yes and okay. If you are going for CBN ball nose cutters and all, of course you can increase the cutting speed. But when it comes to carbide, yes, you have to go for a very high variation carbide. But still, I'm not a very big fan of increasing the cutting speeds, rather more than recommended, because Taylor's law says that 10% increase in cutting speed will reduce your tool life by 50%. That's Taylor's law. So you have to be careful about cutting speed. Now, what is left is increase step over. Can we increase the step over? It's a question mark. Let's see. So everybody knows that scallop height and pitch and step over are related to the surface finish. A good step over will be like this. Sorry, Now let us increase the step over and see. Your scallop height increases. That means your surface finish is gone. So increasing step over is also no. So no productivity improvement in finishing. Look at this. This is a normal profile we have to finish. The scallop height I've done a little bigger. It cannot be this big. And you are using a ball nose cutter. Machine, when balls are going, it comes down. Comes down. So it takes that much time. Now, imagine you have a cutter like this. You're taking bigger step overs. Now, this has taken almost 10 steps to complete that profile. This has taken only 5 steps. So your machining time has reduced by 50%. It can reduce further. Increase the step over, maintain or even decrease the scallop height. You can get better surface finish with barrel milling cutters. Next is the video. Sorry, one second. These are the forms available in barrel mill cutters. This is the first barrel milling cutter which has been there. It has been there for quite long. It was made for machining just barrel-like profiles inside a slot. So it was used only for that in the earlier days. Now, this has developed. You have got a conical with corner radius. You have oval. You have a lens, which is having, it's called as the lens because you can finish the bottom surface also with this. It is something like this. Then you have a combination of barrel and lens. So this has, the technology in barrel milling cutters have increased, has become much better. I'll show you a video. This is a barrel milling cutter for a blade machining. See the step over. That high step over you are taking on a blade machining. Yes, basically, this barrel milling cutters work well in 5-axis machine. Of course, you can do on 3-axis also. Next video, you'll see that. See, the high step overs are the pitch. Let's see the whole video. Because it's a blade and it is taking, normally if there are any people who are machining this length of blade, you know how much time it takes with a ball nose cutter. Let's see how much time it is going to take. You can guess, imagine how much time it will take. It will be very fast. It is taking continuous down milling path. Well, this video about, see, milling is something like just about down milling. Just debating about that. Milling is just like swimming. No, up milling and down milling. See, it's finished. Okay, it is just like swimming. Up milling and down milling. Most of us, all of us prefer down milling because it enters the cut with a thick chip and leaves with a thin chip and all those advantages are there. How it is related to swimming? Imagine you're swimming against the current. Cutter rotates like this, job moves like this, against. Swimming against the current is really difficult. And down milling is swimming along the current. So that's more easier, down milling is more easier. This is with barrel and lens. This was done in India only, Bombay, and I was involved in this, so I'm happy to show you this. Here again says step over, you can see the step over. This was done on a 5-axis machine. Sorry, 3-axis machine. The earlier was on a 5-axis machine, this is on a 3-axis machine. See the surface finish. Here, the whole wall as well as the bottom was done by this combination of lens and barrel. So these are the two good strategies. I am glad to be here and tell you all those things. And if any questions, probably, as Shed said, you can contact me later or ask me later. Thank you.